Okay, I'm answering question 3, and it's explain what is meant by total mechanical energy. That is, total mechanical energy is kinetic energy plus gravitational mechanical potential energy, and it's also asking us to calculate the total mechanical energy of the car at the loop. So we're going to have to calculate kinetic energy and gravitational potential energy. So the equation for kinetic energy is half of mass times velocity squared, which leaves us with half times 500 times 10 squared, which leaves us with 2,500 joules. And then you got to add that to the gravitational potential energy, which is mass times gravity times height, which leaves us with 500 times 9.8 times 16. So that leaves us with 78,400 plus 25,000, which leaves us with 3,460 joules as the total mechanical energy at the loop. And then to question B is using the law of conservation of energy to determine the minimum height needed to achieve the loop speed. To achieve the loop speed of 10 meters per second squared. So, since we know the law of conservation of energy, that energy is not lost, it's just simply transferred to another form. And then we're going to assume that the card is at rest at the top here. So we know that all the kinetic energy is going to be transferred into gravitational potential energy. So we know the gravitational potential energy at the top is going to be 3,460. And once we know that, we can just put it on the other side of our equation, and we can solve for height, which leaves us with 3,400 is equal to 500 times 9.8 times height. You just divide 3,400 by 509.8, and you're left with height is 2.1 meters.